In this video we're going to continue with the topic of exponentials and logarithms b, and we're going to look at exponentials and logarithms to the base e. Now we previously learned, when we looked at exponentials and logarithms earlier in the course, we learned about the exponential constant and how it's considered to be one of the most important numbers in mathematics, and it is also called Euler's number very often. It's known to over 1 trillion digits of accuracy, which you can see a few of those trillion digits on the screen. Now we can actually define e as 1 plus 1 over n all to the power n as n tends to infinity. And basically if you substitute very large values of n into that equation, then you will get a value for e which is very close to this figure that I've stated here. Now you can see here we've got log to the base e of x, and that's obviously a logarithm function to the base e. And this is also known as the natural logarithm of x, and very often we write it ln of x. Okay, so that's just the natural logarithm of x. And we know that the natural logarithm of x is equal to log to the base e of x. So those are exactly the same. And we deal with them in the same manner. So that means that the usual properties of logarithms can be applied to the natural logarithm function as well. So that it stands then, if we've got log to the base e of e, that is equal to 1. Okay. If we've got the natural log of e, then that is equal to 1. So a task firstly, without using a calculator, write down the value of the following. Okay, so always bearing in mind that log to the base e of e is equal to 1. That will be very useful. So if you pause the video just now and try these 7 questions, and then come back and we can go over the answers. Okay folks, welcome back. So this first question here, remember we can apply the usual rules of logarithms. So the argument is currently squared, which means we can bring the power, that's 2, down to be a multiplier of the logarithm function. So that is the same as 2 times log to the base e of e. We know that log to the base e of e is 1, and 2 times 1 is 2. Part B is very similar. Log to the base e of e to the 5 is equal to 5 log to the base e of e. Log to the base e of e is 1, so 5 times 1 is 5. Now the next one, we can see that we've got a root here, and remember the square root is the same as a power a half. So that's log to the base e of e to the half, and then you can see this looks the same as the previous 2 questions, okay? So that's the same as a half log to the base e of e, which is a half times 1, which is a half. Now this one here, part D, we've got the natural logarithm of root e. So that's the natural logarithm of e to the half, which is the same as a half times the natural logarithm of e. And remember the natural logarithm of e, that's log to the base e of e, which is 1. So that answer there is a half. So actually, question C and D here are exactly the same question. Let's look at e now. So that's actually the natural logarithm of e to the power a third. And we can deal with it in the same way as we dealt with question D. So the answer there is 1/3. For question F, we've got the natural logarithm of 1 over the cubed root of e. So remember that's the natural logarithm of e to the power negative a third. And again that then becomes very similar to all of the other questions. That's negative a third times the natural logarithm of e, which is negative a third. And a slightly different question for G, the natural logarithm of 0 cannot be found, explain why. So remember that's log to the base e of 0. So that means e to the power what is equal to 0. Now let's look at our exponential graph. Any exponential graph here, I've just put the general one up, and you can see that actually it doesn't pass through 0 here. So that is why the natural log of 0 cannot be found. Okay. And you can see that anything to the power of something, you can never get that equal to 0. Now, some people might think it's e to the power 0, but remember anything to the power 0 is 1, which is why we've got this point here. Okay, so you can see that that can never be the case. So, let's look at some examples. So example 1, use your calculator to find log to the base e of 8. And we've already learned that log to the base e is the same as the natural log. And if you have a look at your calculator, you will notice next to the log button that there is the button for the natural log ln. So typing in ln and then 8 should get you 2.079 to 3 decimal places. Let's have a look at example 2. This time we're asked to solve the natural log of x equal to 9. So remember, we can express that as log to the base e of x equal to 9. Remember, this is our base, our argument, and our exponent. Okay, so it's e to the power 9 is equal to x. And then, taking your calculator, x will be equal to e to the power 9, and that should give us 8103.08 to 2 decimal places. We still have another example to go, so just now would be a good time to pause the video, take these down in your notes, and then come back for example 3. Okay, welcome back folks, and we'll take a look at example 3 here. We want to simplify 4 log to the base e of 2e minus 3 log to the base e of 3e, expressing your answer in the form a plus log to the base e of b minus log to the base e of c, where a, b and c are whole numbers. So we need to start obviously with the expression that we've been given, and I can see here that I've got coefficients in front of each of these terms. So I'm going to apply my rules of logarithms, and those will become the powers of the arguments. So we've got log to the base e of 2e all to the power 4 minus log to the base e of 3e all cubed. So that is log to the base e of 16, that's 2 to the power 4, 16 e to the 4, minus log to the base e of 3 cubed, which is 27 e cubed. Now, our rules that we've previously learned, so the properties of logarithms, remember if we've got a product within our argument, those can be the sum of 2 separate logarithm terms. So that would be log to the base e of 16 plus log to the base e of e to the power 4. We're then subtracting. Now this is similar to what's happened here. This will become the sum of terms. Okay, so that will be log to the base e of 27 plus log to the base e of e cubed. Okay, but we're actually subtracting all of that. So it's very important here that you ensure that you've used your brackets so that this second term obviously will end up becoming negative in a second. So that gives us log to the base e of 16. Now for this term here, you can see I've got this power here in my argument, so I'm going to bring that down as a multiplier. I've then got my log to the base e of 27, that hasn't changed, and same here, I've got e cubed for my argument, so I'm going to bring the 3 down to be the multiplier of that logarithm function. Now I can see as well I've got log to the base e of e, and I've got it here again. Remember that is equal to 1. So I've got log to the base e of 16 plus 4 minus log to the base e of 27 plus 3. And it's starting to get to the stage where I was asked to express my answer in a certain form, and it's starting to get to the stage where it looks like that. So 4 minus 3 is 1, and I've got my log to the base e of 16, and I've got minus log to the base e of 27. So I have now expressed it in the form it is asked for, and I can see that a, b and c are whole numbers, so I have absolutely satisfied the conditions of the question. So just now would be a good time to pause the video before the screen goes blank, take this example down in your notes, and make sure that you're completing the assigned exercise for today.